So we've looked at the physical processes of reflection and absorption of light rays, and we now understand how these explain why a red apple is red and the ocean is blue. And you'll also remember from the previous lesson that if light rays pass through an object without being absorbed or reflected, we call this process transmission, the transmission of light. We now have to consider a further physical process related to transmission of light rays if we are to understand how the eye works. And this is the process of refraction. Now, refraction is pretty simple, really. It's just the bending of light rays as it passes from one transparent substance into another. We also see refraction in other waves such as sound and water. And I've set up a really simple experiment here. This is just showing refraction using pencils and a glass of water. And it's very simple. If I do this, you will see the process of refraction. Look at that. It's disjointed. The pencil looks like it's in two pieces. It's magic, but it's one pencil. So let's just put that in again, and I'll explain why this happens. So first of all, we need to fill the glass half full with water, and we end up with three different transparent materials. We've got the glass, we've got the water, and we've got air at the top. So we've got three different transparent substances here. We know that light rays from our sun travels in waves through space to reach the Earth. But when light rays pass through our atmosphere or water or any other transparent material such as glass, the velocity of the light rays decrease. And in the PowerPoint presentation, I've given you the values of velocity of light through glass, water, air, and in space. So you've got those four values there with you. And that's because different transparent substances have different densities. So it's important to note there's no change in energy of the light rays as they move through these different transparent mediums. It's purely the velocity of the light rays that change. So the disjointed pencil that we see at the air-water contact is purely due to a change in the speed of light as it travels through water and air. And of course, these two transparent substances has different densities. So what we're going to do is just quickly show you what it looks like from the top. It's even more cray-cray, just there. And we're also going to pop into the dark room just to show you a bit more refraction in the dark room. So that will be the second video. Thanks, guys.